Puget Sound Energy is an electric and gas company, and we serve approximately 1.2 million electric customers and 900,000 gas customers. Microgrid technology has been developing quite a lot over the last decade. We're looking to continue to innovate our microgrids and expand the opportunities as much as possible. Unique opportunity came up with a group of customers out at Samish Island. Each of these customers had residential solar on their house. Also, they were adjacent to a fire station. They really wanted to help the fire station continue providing service during outages.
We face some particular challenges. We have storms that can cut off our road access. We could be isolated for a pretty significant amount of time. And the fire department is our support system on the island. They would be the command center, they would be the resource for helping people.
As Fire District 5, we're trained to help and assist wherever the need is, whatever the time. We need some backup power. And we've been trying to use little generators, but they take time away from responding to an emergency.
That made me think about reaching out to PSE and seeing if there was a way to tie together the solar on the island as a resource for the fire department. They were open, and the idea of solar and battery as part of a microgrid started to evolve.
It's important to integrate your microgrids with the wider utility, but each microgrid individually needs to be able to operate on its own. Built on robust hardware, tested for all possible scenarios. We're learning more and more that there's a lot of ways to apply those things that inverters can do, generators could never do. So it's kind of an interesting and cool time for being in the microgrid space right now.
SCL's product gives us a lot of flexibility in terms of how we need to build the controller towards our use cases. That's a huge reason why we had chosen SCL. And then SCL's engineering services has been very helpful to us and ultimately was a partner through testing and commissioning. The major components in the microgrid includes a recloser, and in that recloser we use a SCL 651 relay, and that gives us a point of isolation from the main grid. Another key component is a front-of-the-meter battery energy storage system that uses lithium-ion batteries to provide power to the grid and to the customers. We also cited a front-of-the-meter solar PV array, which exists behind the fire station. And we couple that with the residential customers' PVs that are mounted on their rooftops. We also have the microgrid controller.
All the different assets communicate back to the microgrid controller, and that's where all the decisions are made to open and close the recloser, change the battery power output, keep the frequency and voltage of the microgrid stable.
A lot of this is being done through automation. This is very analogous to like launching a rocket ship in a lot of ways, and where there's a lot of checks and balances that need to be made. We kind of did a two-step process in the testing. The first one was a little bit more isolated in its own test circuit. And then right after that, we did bring the systems online.
Sometimes when they were testing, it would cause an interruption in the power. So PSE was always very good about informing us and also listening to any feedback that we had.
Testing it on site is the best way to test it. Plan an outage, black out the grid, start it back up again, run the microgrid control system through all of its sequences that it needs to be able to do.
One of our first initial tests, we operated the recloser for the first time, and we were staring at the lights of the fire station and we barely saw a flicker.
I saw a flicker.
That was a great feeling that we had during testing. We have this huge opportunity to give our customers a very seamless experience. We still want to let the customer know that surrounding your area and your neighborhood, there is an outage, however you are on a microgrid right now.
We get a notification if we're islanded and relying on the battery. If it's going to be a short outage and the battery is full, then there's not much that we need to do. But if it's going to be a longer outage, then we need to drop our electricity use.
Having power backup has been a goal of ours for a long time. And now we have power that's dependable, runs seamlessly if the grid's on or the grid's off. Thank you, Bob, because we have a great system and it helps us help the people in need.